Okay, we have an x squared minus x minus 12. How can we factor that?
X minus 4x plus 3.
Okay. Using our x method. Thank you, Sarah. And let's take a look at the denominator. What can we do with a 2x squared minus a 4x minus a 16? What can we do before that? Do you see something before we do that? Yes. We have a greatest common factor. If we go ahead and take that 2 out now, then when we do our x method, we won't have to worry about that a, right? So let's take that out. If we take that 2 out, that's going to leave us with x squared minus 2x minus 8. Now, that will make our x method a lot easier. So bring your 2 over that you factored out. He's still a part of our function here. Negative 4 and 2. Okay, thank you. So x minus 4x plus 2. All right. I'm hoping that you can look at that and start thinking about vertical asymptotes. Is there something we can do in our factored form over here? What do you see? You see that you have a common factor in numerator and denominator, so those need to be factored out. Okay, so we'll just cancel them. We will bring over what we have left, which is the x plus 3 over the 2 times the x plus 2. Where will x plus 3 over 2 times x plus 2 be undefined? At positive 4 and negative 2? Yes. All right, now, but what about that positive 4? We canceled him out, didn't we? Okay, so we're going to hold off on him. But, yes, it is going to be undefined at x equals negative 2 because x plus 2 equals 0 when x equals negative 2. Okay, so that one is our vertical asymptote. It is true that this is not going to exist or be undefined at x equals 4. But since we crossed him out, that brings in, this is something new for you, that brings in our concept of having a hole in our graph. Okay? So, when x equals 4, this will also be undefined. However, since we canceled him out, he is now actually part, or the x coordinate of our hole. And when I say hole, that means we have an open point. So if this is our x coordinate, we're going to put that value back into our function to find its corresponding y coordinate. So we're going to take our x plus 3 over our 2x plus 3, and we're going to put the 4 in. Okay? So if we do that, that's going to give us 4 plus 3. I'm going to move it over so we have room. It's going to give me 4 plus 3 over the 2 times my 4 plus 2. And that's going to give you your y value, right? Because when we sub back in, that gives us our y out. X going in, y coming out. So it's going to give you a what value? 7/12. So that is your hole. So that's your ordered pair. So you found it. So we're good with that. So we found two things. We found our vertical asymptote and our holes, working on what we know to be undefined. Okay. Now we're going to work on our zeros. We're going to start with, let's start with our y-intercept. What is the value of x on the y-axis? 0. Okay? So to find our y-intercept, we're going to set our x equal to 0. Okay, just like we did the 4, we're going to do the same thing again, but with x having a value of 0. So that's going to give us a 0 plus 3 over 2 times our 0 plus 2. So 3 over what? 3 over 4. Okay, so there's your y-intercept at 0, 3/4. Okay, now let's do our x-intercept. Okay, this one's a little different. This is kind of a new concept for you as well, something we really haven't talked about. Okay, if I asked you to tell me what 0 divided by 10 is, what would you tell me? 0, okay? If I asked you to tell me what 0 divided by 30 is, you would tell me 0. Does it matter what you're dividing by if you're dividing it into 0? Any number divided into 0, the answer will always be 0. You agree with me? Okay, so we're going to use that concept to find our x-intercept, right? Because on the x-axis, your y always equals 0. So we need that x-intercept. So really, the only thing we need to be concerned about is the numerator. What is the numerator of our function? X plus 3. Thank you. That x plus 3 needs to equal 0, right? So then if it's 0, it doesn't matter what's in the denominator, that answer or that y will always come out to be 0. So what would that x have a value of? Negative 3. Okay? So that is your x-intercept at negative 3, 0. Okay? So there's your x-intercept, and there's your y-intercept. Okay. And then that leaves us with our horizontal asymptote. All right, your horizontal asymptote uses 3 rules. Okay, it uses 3 rules, or 3 conditions, we could say. You'll have 3 different possibilities. To do our horizontal asymptotes, we're going to go back to before we factored. Okay, we're going to come back to our original. When we are working with horizontal asymptotes, what we are concerned about is the degree of the numerator and the degree of the denominator. And I mean the polynomial, the degrees of the polynomials. So we're going to look at the degrees of the polynomials. I do not want to keep writing those polynomials over and over and over again, so I'm just going to give them separate names, okay? My numerator, I'm going to name him P of X. And the denominator, I'm going to name Q of X. P of X and Q of X. Remember, when we're talking about the degree of the polynomial, we're looking at its highest power, okay? So you're essentially looking at the leading term here. So if we have x squared minus x minus 12, what is the degree of that polynomial? No, the square, the 2, yeah. So that one has a degree of 2. Now, the 2x squared minus 4x minus 16, what is the degree of that polynomial? It is also the square, so it is also the 2. Okay, so everybody clear on what we're talking about as far as degree? All right, very good. Okay, so here's your 3 conditions. One of 3 things is going to happen. All right, the first thing that might happen, if the degree of your P of X is greater than the degree of your Q of X, then you will have no asymptote, no horizontal asymptote. So if you can kind of visualize that happening, we've had horizontal and vertical. Your hyperbolas aren't going to be hyperbolas anymore because they're not going to be stopped horizontally. So they're going to look a little bit different when this occurs. The second condition, okay, the degree of your p of x, is less than the degree of your q of x. If that occurs, then your asymptote, your horizontal asymptote is at y equals 0. And then the third condition, can anybody tell me what it is? If they are equal. If your degrees equal each other. I'm going to make that an arrow. That means your asymptote will be the ratio of the coefficients. So 3 conditions. So what condition do we have here? 1, 2, or 3? We actually have where they are equal to each other, right? We have degree of 2 equal to degree of 2. So we are working with our third condition. And so what we will do is we will take the ratio of the coefficients. Okay, so let's look at our numerator. What is the coefficient of the x squared? What's the coefficient of the 2x squared? 2. So the ratio is 1 over 2. So that is your asymptote. That's it. Any questions on that? All right, so let's graph this. Put in your vertical asymptote. What did we find that vertical asymptote to be? What did we find our horizontal asymptote to be? 1/2. So put that in there. Okay. Where is the y-intercept? 0 and 3/4. So he's kind of right here. Mine's kind of right just underneath there. Where is our x-intercept? At -3. So put him in right there. And our hole, where is our hole? At 4 and 7/12. So it's just above the asymptote. So make him a hole, make him a circle. Open point, I guess you'd say. All right, did we graph everything we found? All right, so let's now go in and graph our hyperbola. So I'm going to come in from the left. I'm going to stay right under my asymptote. I'm going to hit my intercept here and come on down. Oops. Okay. And then I'm going to go to the other side of that vertical asymptote. I'm going to come down. We're going to have to hit our y-intercept. We're going to head over to the hole. You're going to stop right there at that hole and then pick up on the other side. And there it is. Okay, so let's see how we can use our 3 conditions to find the horizontal asymptotes for these 4. All right, your first one. What is the degree of the numerator? No, the degree. Yes, the 2. What is the degree of the denominator? 2. All right. So if we compare a 2 equals a 2, right? So how are we going to determine that horizontal asymptote?
How is it 2?
How is what a 2? The degree, because it's a square, they're both squares. Remember, the degree is the exponent.
That was a coefficient.
No.
It says a coefficient.
Okay, so in that condition, then we're going to look at what for our horizontal asymptote. Going what Marquise just said. He was talking about those coefficients, right? So the coefficient of your numerator is 3. The coefficient of the denominator is the 5. So that's your horizontal asymptote. Okay, let's look at our next one. What's the degree of the numerator? 2. What's the degree of the denominator? 1. So the numerator is greater than the denominator. What's our asymptote? Look at your conditions. What's our asymptote? None. None. When your P of X is greater than your Q of X, or the degree. Okay, let's look at our next one. The degree of the numerator on your third one. What's the degree of the numerator? No. No, the negative doesn't have anything to do with the degree. Yeah, it's just one. Yeah. What's the degree of the denominator? 2. So now we have the numerator is less than the degree of the denominator. What's your asymptote? Y, where y equals 0. So that it's your x-axis, right? Okay, and then our last one. What's the degree of the numerator? What's the degree of the denominator? So again, they are equal to each other. So where is your asymptote on this one? 2, right? Because your coefficient in the numerator is 4. The coefficient in the denominator is 2. We can go ahead and reduce that down to 2. So it is at y equals 2.